Hello everyone and welcome to Handmade Hero Power Outage Edition. We were supposed to start at 9 this morning, at least that's when I originally scheduled this particular broadcast to occur. However, what we quickly found, and by we I mean what I quickly found, was that the power was not actually, the entire, I want to say 6 block square area that the office is in went completely dark. Just was like boom. And I had been playing actually PlayerUnknown's Battlegrounds with some friends, and I was right in the middle of sniping someone out a window, and the screen just went poof, and all the lights went out, and I was like, all right, so I guess I won't be streaming tomorrow. So I posted on Twitter that there was going to be some issues after that happened, when the power it's a long story. I posted some issues that I posted some information on Twitter. It's like, okay, we won't be able to start on time, but the power did come back, so I'll, when I get to the office, we will be able to do a stream, which is going to be later. And so here we are 3 hours later from when we were supposed to be, but we are streaming. So hopefully, the reason I bring all this up, hopefully the power is back in a way that is sustainable, because if it's not, we're going to lose this stream. So yeah, if you see this stream suddenly go dead sometime in the next 2 hours before I actually finish, that is what happened, and I apologize, but yeah. One of the sort of problems of modern life is that without electricity, pretty much nothing we do can continue to be done. And we all have to go back to being cavemen and foraging for food. All right, let's go ahead and get back to what we were doing. Last weekend, I was right in the middle of making some fairly important changes to the lighting. Specifically, what I wanted to do was make it so that the lighting system would receive primarily rectangular elements, right rectangular prisms, sort of axis-aligned bounding boxes, if you will, that would be used as the lighting elements. And so instead of having it be sent down to the system as individual faces, because what we were doing was sending them down individual faces of cubes, what I wanted to do instead is have it so it sends them down in this fashion instead, where you've got this sort of where you kind of have this understanding that the only way that light gets transported around is as a series of these right rectangular prisms, and there's never a case where you've got sort of individual faces happening anymore. So we started that change, and it's in progress. What we did is we made it so that we are directly pushing the lighting now, but we're still directly pushing it on as a series of faces. So when we go to push a lighting element, instead of pushing the cube on as a cube, we are pushing it on as an individual face. Now what I want to do is slowly move from there to, I'm going to do each successive step. I want to slowly move from there to pushing on the actual cubes themselves. But again, I'm trying to take it one step at a time. Now, even though we don't actually care if this code works or not, because we're just sort of doing it to have baby steps, we just want to make sure it's roughly working. It is the case that we made an error. Some folks found it when they were working with the code over the week. It is a case that I made a typo in the order in which the faces get pushed on. Well, I guess it's not the order in which the faces get pushed on. It's actually in how I believe which order the faces were facing, I want to say. So this routine is actually not quite correct. I guess it's this one right here. I'm not sure. I have to go look at it, but point being, some folks found a bug in there, which I'm quite sure is going to turn out to actually be a bug, because I did that fairly quickly, and there's a lot of sort of fussy stuff that's easy to get incorrect. So if we take a look at what's happening here, here's our place where we're pushing on the lighting information. And then if you look here, here's where we're pushing on the lighting points. And then finally, we're pushing on the actual quads, right? And you can see that there's just a lot of business involved here. And this is one of the reasons why I want to keep kind of cutting this stuff down too, is because it's just a lot of information traffic. I mean, all of this work costs real CPU time, and it's just unnecessary because if we know we're kind of got a good way to do the lighting based on cubes, and that's really all we need from the thing, we don't really want to be specifying them as individual little faces because it's just adding complexity and wasting time in the system that doesn't actually give us any benefit, right? If we can express something more simply and more compactly, usually it's a benefit for us to do so. And so that's exactly what we're doing here. All right. So now let's take a look at what the bug was. I have the report. Actually, I can bring it up on the GitHub here. Hold on a second. Let's take a look at the GitHub. I'm doing this on the streaming computer, which is why you don't see it happening. So in the issues list, it says, and this was reported by IROOC, I don't really know how that is pronounced, but switched X surfaces positive and negative in push group render group function. It's specifying that on line 499, which is this one right here. It says we start with negative X, but the first push quad below is this one, and it has the separate quad there. And so the lighting surfaces are just getting swapped on the X, right? It basically what's happening here is this is getting negative X, positive X, but I guess the two faces are actually positive X, negative X for whatever reason. So in other words, in here, right here, P1, P5, P6, P2. Let's see what that actually is. Yeah, so these are positive X's. So that is correct. So this is actually supposed to be the positive X face. And if it's the positive X face, that means its normal points that way. And the same here, the negative X face, it points that way. Similarly, once we flip these two, we've got the x-axis is going to be flipped because it's going to be rotated around. Other than that, they're pretty much identical. There's nothing else that's going to change between them. I don't suspect that makes much of a difference. Basically, all that means is the lighting from one face got assigned to another face and vice versa. So the lighting solution should still run pretty much identically. It's just the lighting would have been subtly wrong. All the X faces, you would have seen the lighting on the wrong side of the cube. So as you moved a light past for X, you would see it on the wrong side of the cube. Now, I don't know if we can really get a look at that happening per se, but let's do this. So this would be the X face of the cube right here, for example. So if I move the light around it, you can kind of see that it is on the correct side of it at the moment, right? And so if I go back here and I flip these two again, if I just kind of put it back the way it was, we should be able to see that face be dark instead, because it's getting lighting from the other side where there isn't any light coming in, right? So if I kind of, yeah, and you can actually see that's exactly what's happening, right? So you can see that light missing there. And like I say, it's kind of a subtle bug because it's easy to not notice, especially in a game that happens to have the x-axis going this way. It's understandable why we didn't immediately see it because all the other directional surfaces are working fine. So, you know, that's why that bug was not immediately obvious to us when we made that error. But I think that's fixed now. That seems okay. Let's test the other side as well. All right. So that seems reasonable, and I can close this bug. We're 421, yeah? All right. All good. While we're on here, what else do we have? There's some Handmade Ray stuff, but not a whole lot in there that we need to look at right now, so we'll leave that. All right. So now all we really need to do is start looking at how we're going to pass these down to the lighting system more directly, right? So now that we know that when we do this push, right, and we do the push cube on here, we're producing all of this business, right? And what we would like to do is replace all of this business with a single thing, you know, just one call that would allow us to represent all of this information more concisely. Now, it's worth noting that we can't really do exactly... Some of this stuff needs to be done explicitly. And the part that needs to be done explicitly is the placement of the points for light sampling on the cube. So, for example, all of this stuff here is all easy to procedurally generate. Meaning we can just say, here is the description of the center radius, the center and radius of the cube, and that's really all you need to know, right? That's a pretty straightforward thing for us to figure out and to have work. So pushing this information on is fairly trivial. The thing that's not so trivial is the point assignment. Point assignment could easily be something that we actually want to vary per cube that we send down. There's a couple different reasons for this. One is that the number of points that we sample for lighting on each cube may want to be proportional to a number of things that are not immediately known about the cube. For example, if it is something that's a very important element of a scene, we may want it to be sampled more densely than things that are less important, and that we don't really care what kind of lighting they get. Things off on the periphery or back in the middle of a forest or something, right? So it's entirely possible that there's actual game knowledge that when the world generator is generating the scenes for the game and it's putting everything down, it's going to want the ability to specify more specifically what these points are and how they are sampled, right? And so in order to accommodate that, we kind of need to be pushing the points on very directly. So that's the part that's going to be the most complicated here. That's the part that doesn't translate directly. This part right here will translate very directly. All we have to do is just effectively push on the center and radius of the cubes, and that's literally it. Like, there's nothing else that has to translate. But the point index, which points go with which faces of the cube and how many there are, that part is the part we're going to have to sort of redetermine or rediscover, or however you want to put it. We need some way of putting that information in, and it's not going to be straightforward. There's not an obvious right way to do that. All right, so let's start with the stuff that we can deal with, right? So what I'm doing here is we're going to pull out the stuff they can all just get collapsed down. So all of this information here, this stuff, this is all stuff that we could specify very succinctly. Okay. So the way that we would do this, right, is we could just say, like, we were going to push on some kind of a light cube, right? Or it's not really a light cube, but it's a light box, let's say. And we know that it's got a minimum corner. And a max corner. And we have that information just readily available, right? Why is this p dot x? Oh, no, we just want this, right? Yeah, because that's the position. These are the positives and negatives. So we know the bounds of our cube. They're right there. So once we have the bounds of the cube, it's trivial to just push that information on. And then from that information, all of the rest of this could be discovered, right? There's nothing else in here that we actually need. There is a transparency coefficient, which we either want to specify per point or per cube. At the moment, we don't have any at all, so we'll just assume that it's per cube. If a cube can pass light through it, we'll maybe put something on there. I don't know, but that's kind of ignorable. Everything else on here is actually completely recoverable just from that piece of information, right? So the light box, all of this work, this incredible amount of work necessary to communicate this stuff down there, that can really all just be moved into the lighting system. And furthermore, we can even bake it into a lot of the equations so that we probably don't even need to explicitly expand this out anymore. The first step we'll do will be to expand it out explicitly, because again, I'm trying to do this in baby steps. It's very complicated. It's not complicated intellectually, it's complicated bookkeeping-wise, and you typically try to take those steps slow so you don't introduce little bug. I mean, we already had one, right? Like that positive-negative flip. So I want to take baby steps, but right, we probably will never even have to generate all of this information explicitly inside the lighting system. We can probably rewrite a lot of our equations, like our raycaster, to operate directly on the box itself, and only generate this piece of information on demand, which again will save us a lot of space, a lot of cache bandwidth, all kinds of stuff, right? So it's potentially very important to do this change, not even just for the fact that we need it structurally so that we can start attacking this problem in a more multi-resolution sense, but also because this is just, even if we were just going to leave the lighting algorithm exactly as it is right now and not make any further improvements to it, we would still be in a situation where we kind of want this to be the case regardless, right? We kind of want this more compact representation no matter what. So the thing that we don't know how to do is we then have this light to point, cube face. These are the faces of the cube that we were recording here, right? Or box. It's not a cube. It has different dimensions, X, Y, and Z. Well, at the moment, the only dimension that can vary is actually Z. X and Y are always the same size as each other. They're always equivalent, but the Z can vary. But that's not a requirement for the lighting system. Anyway, so if we take a look at what's going on here, the problem that we see is that each one of these faces of the cube was previously saying, okay, there's a certain number of things that I record, right? There's a certain number of points that I am accounting. And the problem here is that we don't really have any way of specifying that in the cube in some kind of really concise way. So what I'm going to do is I'm just going to do it in a non-concise way first, and we'll work on improving it later, because we don't really know what we're going to see as we sort of get a little bit further down there. So what I'm going to do instead is just literally record exactly this. If we just say lightbox light index and say that there's going to be 6 of these, then I can just pretty much specify them directly, right? I can just say, all right, there's light index plus 4. You see where I'm going with this, right? And furthermore, we could actually have an extra one in here, and I'll show you why we would do that in a second. So we have 4, 8, 12, 16, 20, 24, right? And there's our 24 pieces of light information, which is exactly how many we would expect there to be. We get rid of all this stuff entirely, right? Well, I guess I shouldn't get rid of it entirely, because this stuff is going to be used probably in the light system. So what I will do instead is I'll just move it over to the lower part of render group where the extract call was happening. Of course, we deleted that call because we don't actually have to extract anymore, I believe. Where is that? Here we go. So in here where we're actually doing the lighting, right before we make that call, you can see we set up stuff for by grabbing out the information from the lighting group, which is this stuff here. So what we would want to do here is just take a second to actually expand this stuff out here, right? All right. So that stuff's going to go there. And I suppose I'm not sure exactly how I want to do the lighting stuff, so we'll look at that. We'll probably do it pretty similar to how we were doing it before, but there we go. If we take a look at what's going on here, we now no longer have to do that fussing with light index either, because it's just going to be it's just going to be exactly what we think it should be. I'm not sure why. Okay, light index is right there. I was going to say it should be somewhere right here. So if you take a look at what I did here is I said, okay, the 0th one is the first light index we're supposed to use. The one element is going to be that plus 4, then plus another 4, plus another 4, plus another 4, plus another 4. That's all the light indices. You'll notice I went 1 over. So this would be if there was a 7th face of the cube. This is, or the box, this is what it would be right here. Now, the reason I did that is because this allows me, if I have a 1 extra element, it allows me to just use the concept that I can take the 1 higher element and subtract the previous element to get the count for any slot. So lightbox light index 0 tells me where I am for the first face of my cube, right? But the next element also tells me if I take what the next face starts at, if I subtract that, if I subtract away the one I'm on from the next one, I get the number of points that I am using for my face, right? So what happens is when you get to the last one, which is light index 5 here, if I didn't put in 1 extra entry, I wouldn't know how many were assigned to the 5th face because there'd be nothing to use as the next bound. So by adding 1 extra entry to the array, it allows us to use it as a set of spans instead of just a set of indices. And so that's just basically a cap, a pad on there for that purpose. Okay, so we can basically pass all of the information, all of this stuff that we were passing before can all be passed effectively this way. And so that's what we're going to do because you can see how much more concise that is. So what we want to do is we want to say that there's something called a lighting box, let's say, and we just call this light box. We now have something called like a light box count. And that just gets added, you know, a plus plus simple on there. I'm not sure why. So this, yeah. So this surface index stuff also needs to kind of get changed a little bit. Since these are packed in order now, this stuff doesn't really have to work this way. This really just looks like that, right? So all we're doing is getting the next light box. And that's all we have to do. And again, we're not really super concerned about any special stuff that's going on here. This is all just pretty basic sort of test code of how we're going to do it. We may not push it on exactly this way in the future, but we just kind of want to get the basic idea here. So the group light index part, that's still going to be the same as it was. So that part, this part still hasn't been sort of fussed with at all. It's really just this part that we're talking about. So now the surface index part, we still have to do this loop in order to put the points on here, but it no longer has to be talking about any particular surface index, right? You can just put these points on directly, and they're all going to come from the same light box. And the challenge that we're going to face here, and I don't, again, this is the part where I say this point assignment stuff is pretty tricky. The challenge that we're going to face here is that we don't really know for any given surface point, we don't know which part of the cube it corresponds to. So we have to kind of see in the lighting system, could we get away with not ever having the backwards index happen? And I think it might be possible that we could, but I'm just not 100% sure, right? But if we take a look here, we can kind of see a little bit more what's going on. So let's just continue down this road a little bit. If you take a look at how these are specified, here's the lighting point, and the lighting surface is here, lighting point is here. You can see the piece of information that we have. This surface index that's recorded as part of the point, the question really is, where does that get used, right? And this is us just pushing it on. I assume that's behind my head there. What's going on there? Why can't I see that? Let's see, render group. There we go. All right. So in the surface index thing here, you can see that really the only place that this is getting talked about is actually in the output function. So that's kind of nice. And if we look at why that is, it's really just to grab those axes, those two right there. So what's really interesting about that is that means we effectively just don't need it, right? That's pretty fantastic. So what that means is this will be even easier than I thought, unless we run into another situation where we find that we're doing something new in the lighting that does require that back pointer, but I really don't want that. Like, I didn't want that there. So the answer is, yeah, we really kind of want something more like this, where lighting points just really do not have any kind of back pointer back to the surface that they're doing. So we will continue on doing exactly that. Okay, so if we go back to how we were pushing these points on, is that a I suppose we probably don't want to leave that in there. This is when we for when we were debugging. All right. Sorry, that was just funny to see that in there. So when we're pushing these points on, that's really great news. That basically means that the points just don't ever have to know. And so we can get rid of the lighting surface stuff here altogether. It's just not relevant anymore. But what we do have to do is have a way of producing the information we actually need to distribute the points as far as where the points are actually supposed to go. Now, we can do this a little bit more procedurally than we were doing it before. And so we can make this probably a more compact, slightly more compact routine than the one that had like all of this stuff kind of blown out completely. So let's try and make sure that we can do that. So here we take a look at what we need for our surface. And you can kind of see all the information that we need, right? And it's the information that we had sort of expanded out in here into individual values. So we need to be able to compute this stuff. And we need to be able to just compute it on the fly inside the loop for what we need. So we need the position of the face in terms of the center position of the face. Although, well, if you look at it, we really don't necessarily need to do it that way. We could rewrite this routine as being just in terms of the positive and negative portions of it. So we could choose to do it either way. Since this isn't a particularly important routine, I'll just leave it the way it is, because this is going to go away, and these will be specified by the world generation code, I suspect, in the end, like I was suggesting. But so what we really need to do here is to have a way of specifying this information in a more procedural way than we were. And there's a couple different ways we could do this. I'm not sure exactly which one is the right one. one way is we can just make it be table based. Another way is we can sort of figure out how to generate it as a tableau where we just kind of look at the pattern that happens in them. So I'm not sure what the most concise way to do this would be. Bear with me for 1 second. We do have a way of looking at the, so if we, at least we have a nice debug view here, so we can look to see if we're generating a sensible set of reflectors. We can kind of get them at a glance here as we look at them. And I would also add, potentially, it looks kind of like we're not really doing a very good job distributing these things. It looks like there's a bug. Yeah, like these are higher than they should be. These are offset upward compared to where they should be. So when we did that port, we had another bug right here that nobody found, which is okay. Like I said, this code is just mungy at the moment anyway. We're just kind of, we haven't gotten to the point where we're locking it down at all, so it's fine. But that computation there is incorrect. Or one of these was incorrect. Like, for example, maybe the width and height is incorrect in some way, or the x-axis doesn't look like those could be wrong, though. Those don't look particularly wrong. So it's mostly this stuff that's looking a bit askance here. I'm not sure why, because it looks well, yeah, I mean, that does, yeah, now that I look at it, that doesn't look good. Anyway, ignore that for a second, because we'll do this slightly differently. But point being, when we do the surface index here, we're going to have some way of translating from a surface index or any other kind of loop. We could do more than one loop. We could do nested for loops if we want to. Who knows? But we need to have some way of translating from like an index for a face of some kind into something that gives us the information that we need. Now, like I said, we don't really need this surface p-value the way that it was before. Instead, and we don't need the x-axis or y-axis or any of those things, actually. All we really need is the min-max that the point needs to be distributed in, right? So, for example, what we could say is that x sub is going to give a proportion of how far along the surface we're supposed to go, and then we just go that far between the min and the max, right? So, for example, if we were to say that x sub, in this case, it's going to be 0 and 1, we divide that by 2 and we get 0 and 0.5. If we offset that by 0.25, we could then just do that far in between, right? So we could do something where we said, all right, we want this point to be, some kind of a lerp in between the min corner and the max corner, x, and some lerp between the min corner and the max corner, y. So we just have like min corner x, max corner x, min corner y, max corner y, and oops, I did not want that to just happen. And that's really all we would need to do, right? So we could just produce something like this, and then we would need the normal to the surface. So we need we don't need this surface index at all anymore. So we just need the surface normal and the min and max corner, right? That's really all the information we actually need to produce. We don't need any of this stuff at all, right? And so what we can do is we can just do it this way, and we know what the x sub ratio and the y sub ratio are. The y sub ratio is just going to be 0.25f plus y sub over y sub count. So that'll give us 0.25 and 0.75, which is, I think, roughly where we wanted to place these. And who knows where we want to place them in reality. Well, like I said, this is just kind of, you know, temporary stand-in code for, at some point, we're assuming we'll figure out exactly how we want to place points when we're generating world geometry. So that just gives us a sort of a generic placement of those points. And then we know that really all we have to do is figure out just those three things: min corner, max corner, normal, right? So it's min corner, max corner, surface normal. And I think that was everything that we actually needed. Oops. All right. So once that's done, then we need to, and we're going to have to go back there and actually do that computation. We need to specify the stuff that we're actually storing here now. And you can see we've got our lighting box that we had started on, but we didn't quite finish. And we had already come to this conclusion, amusingly enough. Put this like that. What we didn't do yet is specify how these like lighting indices and stuff worked. So like I said, I think I'm just going to go with the fact that the lighting indices will be the 0 through 6. So we're going to have 7 of these, just like one extra. We don't really want to have an extra short sitting there, probably. That doesn't sound particularly good. So, you know, we probably want 8 of them for now. Like, I guess we could do it this way. Right? Because we really just don't want, you know, these things to be... we don't want 7 shorts like so there's a 16-bit thing hanging there. We need to think about, you know, maybe there's something we could put in here as well, or, you know, we've basically got a slot to use there. We're not going to leave that fallow. Anyway, so now we have to make sure that these pieces of information are sent down. Let me just take a quick look at this. What is the question? It doesn't like... What doesn't it like about that? That seems... semicolon to match the argument list. Ah, there we go. So, right. Right. I jumped the gun on that here. This is not a component-based add. So what this actually is we need to start at the min corner, right? Because we don't know where in 3 dimensions we are. We're on some 2D surface that's embedded in 3 dimensions, and we want to move along its 2 axes along these ratios, the x sub ratio and the y sub ratio. So we need to start at the min corner. Then we need to go from the min corner, the axis that is from the min corner to the max corner along one way, right? We need to move along that by the x sub ratio, and then we need to move along the other one by the y sub ratio. So it is a little more complicated than I was making it out to be, because we don't have the information that we need just from the min corner and the max corner without looking at the individual elements to see which ones are equal, to know which one we have to move along, if that makes sense. Stated alternately, So, if we assume that we want to produce points like here, 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 and here, which is what we were doing, we need some way of being able to actually arrive at these locations from the information that we have. And the information we have is a min corner and a max corner. But the problem is we don't actually know where those are in space. So they could be, you know, such that it looks like this. Right? It could be such that it looks like this. Etc., etc. So the problem is just how do we come up with a clean way of doing that doesn't just degenerate to exactly what I was doing before? And the answer is maybe we have to do it the exact way that I was doing it before. It may be that we have to just generate an x and y axis because we know that this equation is going to require those two. And it's not immediately obvious to me how you generate that for the min and max. So that's just looking at the elements and seeing which ones they have in common. So yeah, so I think we may have to be a little bit more explicit here, which is unfortunate. I was hoping there would be some really nice way to do this, but I don't know that there really actually is. So here's a thought. Suppose we go by axis, x, y, z. And then for each axis, we do the positive and negative version. Sorry, as I itch my ankle. Do not ask me why I have an itchy ankle. Fleas, probably. So if we go axis by axis and then do positive and negative, then at least one thing we could say is we immediately know the surface normal, right? Because if we assume that the surface normal starts as just all zeros, and then we just go ahead and say, well, whatever element whatever axis we're on, that element of the normal equals either 1 or -1, depending on whether we're on the positive or negative version of it, right? Similarly, I think we could generate the min and max corner that way. So like, for example, once we know which one the surface normal is, it seems like getting the x and y axis becomes relatively, it becomes possible at that point as well, because we can produce the other axes related to that axis probably in a similar way, right? If we assume that we want our thing to be pointing counterclockwise out the axis that we're on, we should be able to do something like, well, just take the cross product with that axis or something similar, right? For example, if we took some other axis we know is orthogonal to this one, so whichever direction the surface normal is pointing in, if we want to produce a coordinate system that is just an x and y axis based on that coordinate system, we should be able to do so. To think about this a little bit more. Let's start with the min and max corner, because I think we can use those as well. So we know that the min corner and max corner of the cube are coming from these right here, and we know what they are, right? So we know just by default that if all we wanted was the min and max corner of the cube, we could just get that, right? It's just trivial. So the question then is, well, if we know the min and max corner of the cube, how do we know what the min and max corner of the face are, right? Because if you look, they're not the same thing. For the cube, if you assume the axes look like this, then this is the max corner and this is the min corner, right, of the cube. But for any given face, you know, like it might be more like this. Like this may be the min corner and this may be the max corner for this face. So whatever, and the way that works, right, is that if it's the positive face, then you're going to replace, like the min and max corner are always going to be exactly the same on two of the axes, right? It's just one of the axes gets drawn back. So basically the min corner, what you're going to do is force one of these elements to be positive. And you're going to force the element to be positive that's whichever face you were doing. So for example, if I'm going out the positive x face, then the min corner's x-axis just has to be moved up to the positive side, right? So that's all that's happening here. Likewise, the max corner is going to do the same thing. The max corner is going to have the same change. And we can write this more compactly, actually, by just saying, well, if it's positive or if it's negative, we do one or the other, right? So in the positive case, we have to move the min corner up. In the negative case, we have to move the max corner back. Right? So that's all we're really doing. So I think that gives us the surface and the min-max corner of the face that we're talking about. So at that point, what we need to figure out is, all right, if we're going to do the placement of something on this face, we need some way of knowing how to apply our two, like, because since we're trying to distribute things along those surfaces according to the axes somehow, we need some way of having the x-axis and the y-axis for that we would move along. And in order to do that, I guess, trying to think of how this would work. So I can't think of any straightforward way to do it. There probably is one. Well, you know what we could do? Let's just do this by Tableau. Because I was going to say we could do the cross. This doesn't seem like we should have to. We should be able to read this off exactly because it is axis aligned. It should be a lot simpler than doing something fancy like that, right? While we're at it, we can simplify this part a little bit here. Right, so this is our fix-up for the positive and negative case. So let's take a look at what our x and y axes actually would have been in these cases. So here's axis. Here's positive. Right? So the axis goes 0, 0, 1, 1, 2, 2, and the positive is just alternating, 0, 1, 0, 1, 0, 1, 0, 1. Right? So now we just need to know, well, okay, for each one of these, what would the x and y axis actually be, right? So here's the x-axis. Here's the y-axis. Maybe I'll leave space. Oops. All right. So the question is, what should each of these be for the order we're doing them in here? So in this case, we've got a surface normal. We're going to start off with axis 0, which is the x-axis, and we're starting off with positive being 0, so it's going to be negative. So the surface normal is going to be -1, so it's pointing out the negative x-axis, right, which is here. Right. So we want our in that case, we want our y-axis to be the the z-axis, right? We did this before. So our y-axis is the z-axis. It's just pointing up, and our x-axis is going to be the negative y-axis, right? It's going to be coming out this way. Does that seem fair? I hope it does. We would then do the positive x-axis, and that means that we would have the opposite thing for the y. So the y-axis, our x-axis is going to be positive y instead of negative y, so it would be like that. But our y-axis would still be z up, right? We would then move on to the y faces. So these are the y faces. So the negative y face is facing out this way. So the z is still going to be the axis for that face that points upwards, right? Now, mind you, we may want this to this might make the tableau harder to do this way, but it doesn't really matter how we choose to do these. So I'm just doing it that way because that's more human intuition when you look at the cube. But we could be more like winding oriented about it and say that it should be this other thing because of the cross product or something, right? So there's other ways we could decide to do this because there's more than one x and y axis you could use that would be orthogonal on this plane and still aligned with the cube, right? There's several permutations you could choose. So anyway, assuming that's the y-axis in this case, then we need to know, well, what is the x-axis? In this case, for the negative one, it's going to be the positive x. And we get around to the other side, it's going to be the opposite, right? So it looks like that. And then finally, when we do the z, we're going to end up with sort of the opposite thing happening here. So if we take a look at what needs to happen for the y-axis in the z case, the y-axis could be a number of different things, but I suppose if we're looking down from the top of it, we would expect to see for the positive z face, we would want the x-axis and the y-axis to be actually themselves. So for the positive z face here, we would expect to have an actual x-axis and actual y-axis, oddly enough. And then when you would flip it around on the other side, well, there's two different ways that we could look at it, but probably the thing we would do is flip the x-axis on it, because what we've been doing is flipping the x-axis, so we'll stick with that as sort of the convention. So in order to skip it, the y-axis would remain the same. So it just looks like this. And instead of the x-axis pointing this way, it would now point this way down negative x, right? So that's for the negative z face. So if you take a look at what we've got here, this is a pretty interesting tableau to look at. The only thing that I would point out is, so you can see what I was talking about before in terms of how the x-axis and the y-axis are a little bit wonky compared to what you might expect. You could probably make this a little bit more of a straightforward tableau by being a little bit smarter about how these two things are set up. Because you can see the x-axis doesn't follow a particularly good pattern. It's like -1, 1, 1, -1, -1, 1, right? Which is, we probably could have got that to be a -1, 1, -1, 1, -1, 1 all the way down if we'd wanted to by changing sort of our rule for how we were doing those. But So the y-axis is pretty straightforward, right? It's just always that, and the only thing that we really have to do is say if axis index equals 2, y-axis equals something else, right? And I suppose since that's the only place I do that, I can just represent that pretty compactly right here. So in that case, you're just saying, all right, we've got the axis index that determines which one of these two we use. As soon as we're on Z, we switch either way. And maybe we need something else here when we do this, we'll see, and then we'd have to expand that back out. But it looks like the x-axis is kind of a little bit wonky just in general. So we need two things for the x-axis. We need to know the sign and then which slot it goes into, right? So down here, we're going to kind of do v3 x-axis. And we're going to do something like, I guess, this. If the axis index is 0, it's going to be that, otherwise that. And the problem here is we need to know what the sign of that is, right? Because it only takes on two values, those two values, but we don't know which sign it is. So we've got two cases where it's -1, 1. So in this case, we could say, well, it's positive based on the positive value. If it's 0, it's negative. If it's 1, it's positive, right? Except for the y-axis case. So we just say, you know, if y-axis, or sorry, if x-axis index equals 1, and now we've got all that information. At this point, I don't think we need the max corner anymore. We didn't end up using the max corner really too much in this. So really all we need is the span, like how far it is to go between those two. So we really just need this value. But, you know, whatever. Now we've got all the information we need, could probably ever need. So in this case, we just need to go, all right, we're going to go the min corner, the x sub ratio, I guess that's not entirely true. I suppose we still want to take the measure of the span on the x-axis and the y-axis as well. So we sort of want our scaled x-axis here, if I guess if that makes sense. But anyway, so we've got our min corner. We're going to do our x sub ratio times scaled x plus y sub ratio times scaled y. And what we need to do is figure out what those two things are. Those are not particularly hard. Once we have our x-axis and y-axis, we just need to figure out how far we would go along them to get all the way to the end. And we already know what that is. Right, that's just the dot product of the x-axis with whatever the span of the side of the face is going to tell us how far along that axis we would go to get to the end of the face, right? And so now we've got a thing that will generate this information for us in theory, and we should be good to go. All right. There we go. Okay. Where are we at here? Here we go. Doesn't like our conversion. We don't have a surface index. And I think that's it. That looks all good. All right. So we're done with that part. And now we have to actually record, like have a place to record that lightbox information. So now I'm going to switch back over to just doing the bookkeeping. Here's the game render commands. We've got the surface and surface count. We are now no longer going to have surfaces. We're just going to have light boxes. Like so. And everyone who initializes one of these has to pass one in. Light point. Oh! Changed the wrong one. All right, and in theory, that will have generated a problem in Win32 Handmade where we're not actually pointing those down. There it is. There's light boxes. And we're good. So I think now we've got everything done except for the part where we actually light with these, and we'll take that again as sort of a slow step process. So what I think we should do here is just blow out, using the same algorithm we were using before, actually blow it out into the same set of surfaces from every lighting box that we got recorded. And we know what those were. Effectively, we could use the exact same routine, in fact, I suppose, when I think about it. If we want to, we can take this same algorithm we were doing here, which generates this stuff. We could actually just make this be a function call that you call, and it gets you this information. That seems pretty good to me. So it would just be something like this. Where you just ask for this stuff and you get it. So basically, like, so you just need the min corner and max corner to be passed into you, I think, is pretty much it. You would pass in what the min corner and max corner were and the surface index. And then it would just pass you back a result which just had all these things in it. So you do lightbox surface results, surface n. So we could just call that n. The span. Y-axis. Whether we need the scaled Y and scaled X, I don't know. I'll leave them there for now, but now you've got all the information that you need to reconstruct one of these guys. And again, I'm just doing that so that way we know that they're computed the same in both places, right? Because we need these two things to line up, and so we want this, as much as possible, to use similar code to extract them, so that if we change it in one place, it'll still be reflected properly in the other. All right, so these lightbox surfaces, as they are coming through here, let me grab this out as well, because it's kind of more appropriate to this routine now. So this getBox surface call, we can just do lightbox surface, getBox surface, oh, whoops, it's not surface index, sorry. It's axis index positive. It's that. And we could just pass in a single index here and just generate those two from it. And maybe that's the better way to do it. I don't know. So, you know, for example, what we could do is this. Suppose you were to pass in a flat surface index. So this you just pass 0 through 6. Well, we know the low bit is just whether it's positive or not, right? Because that goes 0, 1, 0, 1, 0, 1 already. So positive is just surface index and 1, right? And the axis index is just the surface index shifted down by 1, because getting rid of that bottom bit. Oops. Right? So we could just choose to do it this way, and then it's a little cleaner as well, I suppose, because then you can just say like, all right, I'm just going to go through the faces of this cube, and I don't want to have to like keep doing all these loops and stuff, because why bother? It's just more bookkeeping. Let's just do it that way. You know? So that's one way to do it. Seems pretty reasonable. You know, who knows if it actually is or isn't. So in this case, you see we've got the px nx thing here, and we don't actually know what those are anymore because they haven't been passed in. But we actually do know. This was just because they happen to be in that routine that we did it this way. We could have easily said, oh, and you know what? This shouldn't be nx and px anyway. This was a bug anyway. These should actually be based off of the axis index. So this should be whatever the axis index was, right? It should have been this. Right? But anyway, the point being is just because we don't have the p and n values doesn't matter. They got passed in as min corner and max corner anyway. So really, it's just this. It's really just pulling from these anyway. So that doesn't matter. And hey, we found a bug, which is even better. So we got a free bug fix out of it. Just the same. All right. So we just need to access these off of surface now. So we'll do that. And then in here, and maybe we'll call this box surface index like so. So all we need to do now is we need to extract each one of these out. Excuse me as I stretch. And we don't really need any of this anymore, right? All of this information we can get from what we have now. So really what we just need to do is translate this sort of systematically, these lighting surface values. We just need to translate those systematically back into... from the lighting box routine that we just wrote into this routine, and we'll be done. Well, modular debugging, but you know what I mean. All right, so anyway, we've got getBox surface here. And that requires the min corner and max corner. We're going to have that. because it's going to come in as the box that we're reading off of. And then we need to create this stuff. Fortunately, we only have to do it we only have to do one of these because this loop will now take care of all of these, like so. And we also need to be able to generate that other information that we cared about, which was, if you remember, inside that lighting surface thing, we have to do the light index and the light count as well. Okay, so if we take a look at what's going on here, producing the surface P, it's basically the same thing that we were doing before. If we were to take box surface, or rather box min corner, start at the box min corner and just do box surface scaled X, box surface scaled Y, this would produce, oops, it's not true. We need to record one more piece of information here. That also needs to be there, right? We need the min and the max of the thing, or just at least the min, right? And the span, that gives us the min and the max the way that we want. Actually, I suppose the span we can just go halfway along as well. So we could just say box surface min plus 0.5x times box surface span. That gets us halfway across and into the center, which is what we wanted. And so that's a bug in our other routine as well. Let me just go fix that so we don't forget. Get box surface. In here, this isn't min corner. It's actually the min as computed by this routine, right? Min corner is not supposed to be used except just to call it, right? And in fact, we could avoid that being used. Well, we don't really want to, though. I mean, we want that to just be made once and used here, but you know, either way. I guess we could do it this way. All right, so taking a look at what we've got here, I think that's pretty much how we want to do it. And so now we just have to loop, we have to actually have a place to put these and make sure that the light indices line up. Before we do that, I want to make sure that this routine here records the min-max, the min-corner, max-corner. So result min needs to be min-corner like so. And I think we're good. All right. So that all seems good. Now what we need to do is actually create these arrays here in some more sensible fashion. So what we've got is this sort of lighting solution here where we were pointing to surfaces before. We don't want to do. We actually want this to be a real thing now. And what we're going to do is we're going to loop over each of those input boxes that we got and blow them out into actual surfaces. So we know ahead of time what the surface count is going to be. The surface count is just going to be whatever the box count is times 6, because we're just, you know, running through them. And we know that the lighting surface, we should also probably assert or I can even do it by count solution surfaces, like so. So if you take a look at what we want to do here, we need the surface to sort of slowly go through here. So, you know, as we come through here, we just want to start at the first surface. As each of these goes through, we record one new surface and advance the surface pointer, and off we go. So all we really need here is the box index and the box count. And we need to pull out that box that we're, the source box that was pushed on. We need to pull that out. From here. So where are we going to get the box count from? Well, it should, in theory, have already been recorded. Right? It should have been recorded when we pushed the cube on in the first place. So it should have been recorded right here. So we should have that information available. Once we get here, we just need to actually fill in the rest of these piece of information. We're not really doing transparency yet, but we can pass it through. Oops. The width and height of any particular face is actually, now we know that as well. Again, it's the inner product. Which we could have stored in the box surface piece of information there, but we kind of didn't. That might have been a mistake. But anyway, box surface, the inner product of the normal and the span. I'm sorry, that's good. The x-axis and the span, and the y-axis and the span give us our width and height. We know these two axes because they already got computed. So all we really needed to know was the light index and the light count. And fortunately for us, that actually was recorded in the box information, right? The box has a light index field, so whichever surface we're on, that's the one we use. And we can actually just take whatever the next one would have been. Remember I said we put an extra into the array to figure out how the count corresponded. So that is, again, a lot of bookkeeping, but that is basically it. There's really not anything else to it. Off we go. Now we just get rid of that residual there. Surface index. What are you talking about? So for our debug output, where we're doing output lighting points, we have a couple of choices here that we can, how we choose to output this information. And I'm not sure exactly how we want to do it. We don't store the surface index anymore for a lighting point, and we don't want to, right? We don't want to be in the business of having back pointers in our low-level rendering stuff, which is effectively what that was. So the more we can get rid of stuff like that, the better. So the only place that we're actually using it is in the place where we're doing sort of debug output, right? And the debug output is not essential. So we'd rather just spend a little more time in here and generate something we can use without having to have a back pointer, rather than compromise our whole rendering data structures just to put in something that's only necessary in debug. I mean, we could if debug it or something like that, but I don't really want to do that if I don't have to. So if we delete the fact that we're getting a surface at all, we'll immediately see the two places we need it, which are the two axis values. Now, the bonus here is that we could just choose to use we could do two things. We could choose to generate an axis, or we could actually just make the axis into some kind of a temporary array by looping through the surfaces and outputting the axes there. And I feel like that might be a more fun way to do it, because then we actually are seeing which axis is actually being used, because there could be bugs in that, and it would be nice to see that, rather than generate it from the normal, which we have, and assume that the axes were correct on the way in. Right? So hard to say, but that's the basic idea. And I don't really know which one we want to do. It's really hard to say. Again, it depends on whether we want these to be debug things or not. Yeah, so I think I'm going to do it this way. So here's the way I'm going to suggest we do this. Here we were being rather literal. We're saying, well, we want to output the lighting points, let's loop over the points. The problem with doing that is that if we do that, it means that we don't actually know what surface they came from. But what we could do instead is just loop over the surfaces, right? And if we loop over the surfaces and then loop over the points, then we would know what the x and y axes were because we could get it from the surface. Right? So just by changing the way we were iterating it, we can get at that information. And that's all we need. What is the problem? Light index and light count. Those are signed? That must just be integral promotion because they shouldn't be signed. They're U16, so it must just be integral promotion. If I was to change it to that, it shouldn't complain, right? Yeah. It was promoting this U16 to a S32, I guess. These integral promotion rules are not fabulous. All right, so let's. I think we have put everything in place that we need to for this change, but we may have buggy boos all over the place. So let's go ahead and start stepping through there. Let me make sure I get a clean build on this as well. Okay. And start debugging these. So let's see. What is the problem here? So it looks like our surface is sort of off the end as we were looping through it. Can I inspect? Oh, I'm like, why can't I inspect anything? We're in release build. Try it one more time. All right. Yeah. So if we take a look at our surface, you can see here that it's bogus, right? It sort of has valid memory up to about here, and then it becomes not valid memory. So first thing I want to do is figure out what number we're on. So you can see we're not even, something's wrong like right off the bat here. It's just bad. So let me take a look at, is that, did I define that wrong? Make sure I even defined it correctly. Oops. So we should have a ton of these, right? We should have a ton of these. So let's see what's going on here. So solution, surfaces. So these are all fairly valid. So all of this looks, well, that's our first problem. I have no idea what that was about right there. Do you see it? Like, what is happening here? I don't even understand. It's just, so it's just gonna stay in this loop forever, basically. Incrementing surface ad infinitum till it runs out of space. So yeah, that's not great, you know? Not a particularly good idea. All right, so we are sort of part of the way there, but you can see we're messed up, right? We should arrive back at the same sort of lighting that we had before, but we're nowhere close, right? This is not even really lighting. It's got stuff on kind of weird signs and so on. I'm going to go ahead and switch to being able to view the information that we should see pretty clearly what's going on. Like it should be completely wrong, right? So this should have shown us our lighting points. We don't see any of them at all. So we've got a bunch of work to do. Let's get started. First things first, I'm just going to jump into lighting test and just get a sense of what the data looks like. Like how wrong is it, right? Does it look sensible in here and maybe it's just subtly wrong, or is it just completely fanciful, totally stupid, like there's all kinds of problems, whatever. So let's first take a look at that box surface routine. And what we can see from just quick inspection of the box surface routine is it's not ludicrous, right? Like all of these things make some sense, but one thing jumps out at me as being obviously wrong. Our x-axis and y-axis are set to the same thing. And I don't know about you, but chances are if I go to define something with an x and a y-axis and they're the same, I'm not going to get a lot of value out of that because you can't actually make a two-dimensional surface with only one dimension's worth of axes. So what is the problem? Well, for starters, the problem would appear to be, wait, that shouldn't, oh, okay. That's the problem. I'm like, that looks right. Well, turns out if you assign the x-axis to both of them, you don't get very far. All right, let's try that again. Also, let's take a quick look at what the result is if it's any different. I'm assuming it's not, because that would not have been sufficient to cause that problem. Well, it's a little bit different, so I guess it was enough different. All right, so you can see here these are the surfaces that we're now working with, right? You can see them pretty plainly. They actually don't look all that wrong. They're not right. Like you can see, we're getting some weirdness here. The positive Y surfaces look kind of like they're not working at all. Because this is the light right here, and we should have been seeing some light on that. It's okay that we're not seeing any light back here, but you can see that's kind of looks bogus. The other thing is, well, yeah. Let me also take a quick spot check at the timing. How much time we got left? How much time do we have left? 33 minutes. We have a half hour. So we should be able to debug this in 30 minutes. That's a lot of time. I did not get much sleep last night due to the power outage. It was kind of annoying. I had to fumble around for some lights and deal with wondering about what to do with the refrigerator and all these sorts of things. Anyway, it doesn't matter. Anyway, so running this in release mode, yeah, so it's not like super slow right now or anything. So it didn't take a massive hit or anything, but so we're not too far off. But you can see like only some of our surfaces ever get light on them. We probably have some index mismatches, or some of the faces are not being computed properly, or various other things like this, right? All right, so let's slowly go back through this and let's try to figure out where we're at. So I'm going to switch back to debug mode here, and I'm going to just, first things first, we introduced that light box surface routine, and I would like to kind of go through it and have some understanding about whether or not I think it's producing results that are plausible, right? So I'm going to go into the pushCube function, and you know, kind of after we do all of this business here, and we come down to specifying the light box, I'm going to just take a quick look and make sure that like all of its data is correct, and then I'm going to look at what we get for that routine that generates our various pieces of information. So our light index values 1, 5, 9, 13, 17, 21, 25 all look valid. 0 obviously is reserved, so as for not having any lighting. So it makes sense that that starts at 1 and goes up the way it does. That's exactly what we would expect, and it's all good. Min corner, max corner certainly seem fine. Nothing particularly odd there, and transparency is currently ignored. Service index, now we loop over, and we're going to go through 6 different 0, 1, 2, 3, and 4, and 5. And then we're going to take a look and see whether we're getting sane results here in terms of how we distribute these points. This is more or less all I really want to know. Okay, so let's suppose I come in here to the box surface call, and I want to look at what the axis index is. It's 0, meaning x-axis. Positive is 0, meaning it's the negative x-axis. That's what we'd expect. I mean, 0 shifted down and 0 ended with 01. Both will produce 0. So we're specifically talking, I don't know why this screen is flickering like mad. The GNOME 3 or whatever it is has all sorts of weird bugs in it for window compositing. It's weird. Anyway, so this is the case that we're specifically talking about here. Here is our normal, and we're going to compute that by using a knockout here. Here is our span. That is that is incorrect. The span has to be computed after this. Hold, please. Before we go any further, let me fix that, because the other values that depend on it are going to be wrong. Yeah, because we can't take the entire distance between the minimum and max corner of the cube. We want the distance between the min corner and the max corner of the face. Right? Yeah. I think everything else is fine. All right, so if we now go ahead and try this one more time. Let's take a look at what we get. So we've got our min, and that should be just the same as the min corner in this case, because it doesn't have to knock out for the positive negative case, so it's all good. So these two should be equivalent, and they are. The span should just be what it takes to get to the max corner in 2 of the dimensions, but not the other. So since we are talking about, this is the positive x face, there should be no span along the x-axis. So the min corner, max corner, we should see this reflected in the span and this reflected in the span, but not this, right? And that is what we get. That's exactly what we get. So that's great. That is what we want. The normal, again, negative x face should be negative x, and it is. X-axis and y-axis look plausible to me. And our scaled versions also look plausible, right? So that's good. We now need to just distribute points on the surfaces. Our light index is 1, which is the point that we would expect to be distributing, so that's good. We have an x sub ratio and a y sub ratio. Oops. So we have an x sub ratio and a y sub ratio of 0.25, which is what we would want. And we're going to set the surface normal for this light thing to be whatever our regular surface normal was, which we did. We're going to take the surface min, and we're going to add the x sub ratio and the scaled times scaled x and the y sub ratio times the scaled y. We should get a point that's still within the bounds. It should be, but it should be pegged to the minimum x, which it is. And we do, so that's good. We set the ref color, add the light index here, which is what we would expect to do, and we're off. This won't change substantively. These are all the same, just with 75 now. And now we come through with another surface. So now we've moved on to the positive Y. And I guess I do still want to see lightbox min corner. Oops. Lightbox max corner. It correctly set X to be the positive version now. So that all looks good. Normal looks correct. Yeah, everything looks fine to me. So now we're on Y negative. That looks right. That looks right. Those look plausible. Yep. Yep. So that now, oops, oh God, I don't do that. How do I make it stop? Okay. So that actually looks fairly reasonable. So I'm not sure why now we're gonna have to go look at the other side of the routine, because that looked pretty plausible to me in terms of the surfaces that were being generated there. So I'm not sure exactly what we're seeing as a problem there. So we're gonna have to go look at the other side of it, unless I missed something. This routine looks like it's reasonably solid now. I didn't see any obvious problems with it. Furthermore, when I run this and look at the locations where it put the points, they're actually more correct than they were before. This now looks like they're actually in the correct locations, whereas before we actually looked like we had a bug there. So I'm fairly sure that we're at least not, grotesquely wrong in some way producing those lightbox functions, because these now all look like they're in pretty reasonable positions. What I don't know is whether the correspondence is correct. One thing that you have to remember here is we're in a bad position in terms of using that debug view to tell us whether or not our lighting points correspond with our lighting surfaces correctly, because the lighting surfaces are all regular. They all go negative x, negative y, negative z, positive z. That's it, right. And when we're doing our debug output, we just go by surface. So if all of the surfaces were assigned to somehow the wrong lighting information, you would not know, because the x-axes are always the same for them all. So as long as they were only off by one whole 24 block of light indices, you'd never know. Because it's not like they all have different axes so that you would see that they would be spun improperly or something, right? So that particular view doesn't really tell us, we'd have to add more information to that debug view in order to tell us stuff like whether they were corresponding properly. Let's go ahead and take a look now at the place where we actually pull this information out temporarily. Again, in the baby steps kind of a paradigm. Let's just go in here and see what we've got. So it says that we've got 77 boxes that we're processing. That seems reasonable. We figure that that will generate 462 surfaces. We're going to loop over each of the boxes one by one. When we pull them out, we're going to ask again for this piece of same box calculation to be run. And then we're going to generate a point by taking the min and going halfway along the span. That should put us in the center, which is what the surface wants. And the box surface tells us the normal. Oops. So here's our source and here's our destination in a sense. Let's take a look at what our width and height are. So really, we want to know the absolute value of that in order to get the width to be correct. Because if it's pointing along a negative axis, that will be negative. So I guess that sort of implies that what we would prefer is that we always were pointing along the positive versions of our axes. See, there's a couple ways to interpret this, and it's tough to say. I guess we would want to say that the min value is not really a min value. That's the wrong way to think about that. Let me just discuss this a little bit here. It's a little subtle. So because this face can be anywhere, min does not really mean min. It doesn't have to be the minimum. Right? It's not necessarily minimum anymore relative to what the x and y axes are. It's the minimum in absolute axes, x, y, z world space, but it's not necessarily minimum relative to these because it might be the x-axis might be pointing along a negative direction, in which case it's actually the maximum now because it's the minimum for the non-negative version of that axis. So it's really more like a base point is probably the right way to think about it. It's basically saying like, hey, with the base and the span, you can get from the face out to the the end of it, but it's not really telling you anything else. And the x-axis and y-axis don't necessarily point out from there. And we need to sort of fix that, I guess, is the thing. Yeah. So I think, yeah, that's just a little tricky. So maybe the way that we were doing it before was better because it's just a lot less room for error there, I guess. So maybe we'll stick with sort of roughly the way we were doing it before, because that is like a little clearer, and I want to avoid that error that I just made in terms of how I was thinking about it. So yeah, if we take a look at what we'd have to do this, this all is still fine, right? We can produce all of this information in terms of the min and the max corners of it. But now what we want to do is say, all right, we want to generate a p-value, and we know where that is, right? We do know that the p-value is just going to be the min corner. We don't want this. The p-value is going to be halfway between the min corner and the max corner. That's the center point, right? And so that gives us the information that we need to. That gives us this, because now we have the center point. Now, if we want to know what the half width is, we just need to take the absolute value of what the span would have been and times those axes. So I guess I still do want this, and we still can do it this way. Same equation, but just written slightly differently, right? So we still do want this because we do need to produce those width and height values. So the absolute values those gives us the width and height, and we can store that half width and that half height directly out of that. And I think that's a saner way to do that. And we just won't store the span at all. I think I like that better. And so here, yeah, we can do the same thing we were doing before. So we'll do basically the same construction. Like so. And what I need to know now is I need to make these x sub ratio and y sub ratio things be more about going halfway in either direction, right? So it's really just, it's pretty straightforward, right? Because of the way we happen to have written it. It's really just this. It's just you start at negative 0.5, so half in the other direction, and then we switch to half in the other direction when we go to the next one, because we just happen to only be doing 2 at the moment, so it's pretty straightforward, right? This becomes now incredibly simple because it actually is the information that we wanted, and this can be used basically directly. And off we go. So yeah, let me just, I want to see that debug view again. All right, so this again looks roughly correct. No obvious errors here that I can see. Well, actually, I don't really know what's going on with some of these points there. Oh, I do. I know what's going on. Those are just very tiny. That's what's going on. So the size at which we're drawing the lighting elements themselves is actually bigger than the size of the cube, the lighting cube. I think is that's what I think is going on there. All right. So it looks like everything else is fine. I don't see any other issues. All right. So I don't see any other issues with the exact output there, but again, we're still not quite home free because we're not getting, the lighting still doesn't look correct. You can see it here if I run it at full speed. We're getting what appears to be reasonable lighting on some surfaces, but not others, right? So we're definitely getting some weird like assignment stuff happening. Possibly with the light indices, it's hard to say, but it's definitely wonky. And it doesn't look like it's properly reflected in this view. Pun intended. So we're almost there, but we've got a little bit more work to do. So if we want to, we have to sort of figure out how to make, how to debug that correspondence a little bit better. Maybe I should try to update that view to show us the information we need. I'm not sure exactly how I would do that at the moment, which is why I'm not doing it. If I had a good idea, I would go do that first. The light index here, you can see exactly, it's just getting read out of the boxes as we would expect. And we're doing this subtraction here to determine how many of them there are for any particular surface. And we're assuming that they got pushed in that order. Now, I don't think I ever really verified that fact, so what I could do first, just to avoid any obvious stupidity, is I could go and make sure that when we do the push, we're pushing on the values we think we're pushing on. So if I step into push cube, in here, you know, we go through this index store process. We say, okay, we're gonna, I don't know why light count is 4 specifically. But whatever. So in here we set the light count to 4 because it's 4 per surface. We advance the light index so that we allocate that many of them. This again is sort of a to-do because we don't really properly do the allocation stuff we're supposed to do here, but that's sort of a separate issue. Then we have the light box that we pull out, and in there we put, you know, the 1, 5, 9, 13, 17, 21, 25, right? And coming through here, we do 1, 2, let's see what we get up to here. Yeah, 25, so that's correct. We then reset it back down to 1. So those look like they're getting pushed on. Oh, but we have not reorganized these to be in line yet. So that makes perfect sense. I forgot one piece of the puzzle there, which is that in here, as we're going through, obviously when we push these on, they have to be in the same order as our new routine, right? So that's negative x, positive x. Negative x, positive x, negative y, positive y, and so on. So let's just go ahead and reorder these to be in that order. That's the first thing we need to do. So if we take a look at 0, 1, 2, 3 here, 0, 1, 2, 3 is the positive z face. So the positive z face is actually the last face. Might as well write these down. 7654 is the negative z face. Um, 4510. Negative y. 2673. positive Y. Light count, yep. And now we've got 1562. 1562. Those were all positive X. So this must be negative X. Seven 403. And now we're closer. We still have some issues here, like I'm not seeing light show up on there, but we're definitely getting a little closer, so that's something. Also, let me take a quick look here so I can move around and just see how the light is playing off the surfaces. So it looks like we still have a face inversion there. Right? Like, maybe? Those faces don't seem to be getting any at all. Like, there's the light, and yet there is no light on those surfaces. Which I don't understand. Because they're being output apparently properly. I don't know why the positive Y and negative Y are reversed there. That must be a cut and paste bug. I doubt that is sufficient to cause the problem, but maybe if we're lucky, that's all it is. I don't think so, though. It looked worse than that, but no, maybe it wasn't. It looked worse than that, so I'm not quite sure we're out of the weeds yet. All right. So that's seeming pretty good now. Again, not quite willing to say it's 100%, but it's looking pretty darn good. And I think we should be at the point where tomorrow we can start first thing on actually making the lighting algorithm just work with the cubes directly, which I think will also give us a speed improvement. Not that we're necessarily at the point where we're trying to optimize that level of it yet, but just the fact that it won't have to deal with as many surfaces should provide some additional speed. And hey, we're right in time. Questions? Is there any way to put a breakpoint outside Visual Studio? Can you be more specific? Do you mean you want to tell Visual Studio to set a breakpoint from another program? Or do you just mean you want to issue a debug break? Like just... I'm not sure exactly what you mean. Can you be more specific about exactly what you want to have happen? The answer will possibly vary. This, by the way, is a nice profile right here because we can basically see all of our time spent in compute light propagation, which is exactly what we want, because that means that as we do the speedups, we should be in good stuff. Let me see what the other question is. What do you think about the blockchain future? I have no idea if questions outside the game are allowed. Generally speaking, I answer on-topic questions. The pre-stream is for off-topic questions. I have already answered the blockchain thing. Basically, I don't really understand the point of it. It doesn't make a lot of sense to me. My short answer is currencies aren't hard. The central problem of currency was never that we didn't have a mathematical way to do it or something. Like, I mean, yes, that's an interesting thing for humans to have figured out, but that's really not the hard part. The hard part about currency is enforcement. I mean, that's the hard part. And enforcement means having an army and a police force. That's what currency is. Currency is... Because, you know, we could do whatever we wanted for currency. I could give you little pieces of paper that just said something. That, you know... The hard part about it is enforcement. What do you do when somebody doesn't honor a valid version of the currency? And blockchain is just about saying there's a way to prove who owns something, to weaker or stronger sense. But that's not the hard part. Who cares if you can prove it? Is the other person gonna pay? That's the important part. And so the only reason blockchain can exist at all is because it exists within a system where governments have armies and police forces that force you to honor contracts. And that's what a currency actually is. So there is no blockchain future. That's not a thing. Currencies require armies. Without an army, you have no currency. You can be a sub-currency inside of someone else's currency regime who does have an army and a police force, but that's all you'll ever be. To me, this is like very obvious to anyone who's ever read any history, so I don't know why people even think there's anything interesting about blockchains in terms of a future way that currency would work, because there isn't. But somehow this escapes people's understanding, and maybe I'm missing some really obvious way in which these things can be enforced, but Math doesn't enforce itself. You know? I mean, someone can say that 2 plus 2 equals 5, and there's nothing you can do about it, right? The math itself, it's not like the laws of physics where you can't break them, right? That's not the kind of math we're dealing with here. We're just dealing with abstract math, and yes, you could all say, well, now we have a way to verify, I can verify that you actually did this thing you said you did. But that's not the hard part of currency. That is a very irrelevant part of currency. The only time you would ever care about that feature of currency is in the case where you already had a functional enforced currency system and you need to create a sub-currency. But who cares? Why not just use the actual currency? Because you're still going to have to obey all the laws that sovereign who gives you the original currency, you're going to have to obey all their laws. Because they have the army. They can just tell you tomorrow you can't do anything with that sub-currency, and you can't. Game over. Right? So, sorry to rant about it, but I don't get it. I do not understand what people are thinking. It seems like a tulip bulb craze nonsense thing to me. But shouldn't we go back to do more stuff in assembler like on the Amiga? Yes. If we could just have the Amiga back again and that was what we made games on, that would be awesome. How do you jump to function during debugging? Usually there's a lot of functions and not easy to find them. I don't have a good way of doing it. I mean, you've seen how I do it. I wish the debugger were built into 4Coder, because there are ways to do it in here. Like you can do like push quad and lists all the locations of that that it's called and also where it's defined. But that doesn't work in Visual Studio. Like you have to have like browse info turned on or something to do that, and you can't do that without a project. And we don't have a project for Handmade because it's not built using their build system and blah blah blah, right? So I don't know how you do it in the debugger, but I'm just hoping that someday we'll have a debugger built into 4Coder and I can get rid of that Visual Studio nonsense anyway. But I don't have a good answer for you. John tweeted once about how X-forward right-handed coordinate systems should be standard. Do you know details on why is that important? So I don't know why that's important, but I don't know why John said that, but I can hypothesize some reasons why he might have said that, but he is a better person to ask, and he does stream programming fairly often, so hopefully you could ask him. The choice of coordinate systems is 100% arbitrary. If nothing else, I guess Einstein taught us that maybe, or something. The choice of coordinate system is completely arbitrary. Frames of reference are arbitrary. So there's nothing special about a right-handed coordinate system, and there's certainly nothing special about an X-forward coordinate system. So it's important to understand that first and foremost, and I would suspect John would tell you exactly the same thing. I can't speak for him, but if I had to guess, I would say he would say exactly what I just said. The choice of coordinate system is 100% arbitrary. That said, it is an unnecessary complexity to pick them arbitrarily. When we all talk to each other about routines and we write shared libraries that each other want to use, and we read matrices in print that we need to understand, having an arbitrary sense of here's a left-handed coordinate system, oh, this one's a right-handed coordinate system, oh, this one has z facing up, oh, this one has z facing forwards, oh, this one has z facing right. Having all of those complexities just wastes programmers' time because they are constantly suffering from mental overhead of remembering they have to translate these things, right? So it's kind of like saying your choice of language is arbitrary. Is Chinese a better language than, I don't know, Indian? An Indian language is better than a European language, French, let's say, or something like this. Who knows, right? And the choice of language, there may be slight pluses or minuses to some language. Maybe, this writing system is harder, or this one has more ways of expressing tense or whatever. But largely, we know that humans can communicate in any of them. So you might say, well, let's just write books in all the languages and everyone just learns to read all the languages, right? But we know that that's ludicrous because it's so much more mental overhead to do that. It would obviously be way better if we could just standardize on one language and then everyone could just learn one language and they wouldn't have to have all this mental overhead and there wouldn't be things that were difficult for them to access, right? So that's kind of the like extreme example, but scale that back to the coordinate systems, it's just like a language. You start to learn all of the ways to interpret what you're reading quickly when you know that it's always one coordinate system. You're just like, oh yeah, I know the right-hand rule always applies, so when I see these two things, my brain just does this, right? I don't have to stop and think. And so I suspect that was what John was talking about, but don't really know. So from my perspective, yeah, if we did standardize on a coordinate system, that might be a nice thing. And the reason that might be a nice thing, even though the choice is arbitrary, is because much like language, it would be nice if we could just eliminate that work. Eliminate that work that people have to do of learning and relearning and translation in their head in order to work with things written in these different systems. And obviously for language, it's a much worse problem than for coordinate systems, right? Languages is an infinitely harder situation than coordinate systems, but it's the same basic principle. If you allow people to start making assumptions about what is true, they can be quicker about how they do things. Whereas if they constantly have to recheck those assumptions and always be like, wait a minute, oh, wait, which axis system are we using? Oh, right, okay. That's just a mental overhead and a source of potential mistakes. I mean, another example would be metric system versus standard, right? In that case, unlike coordinate systems, there's some real obvious ways where the metric system might be a better choice, right? There are some ways the English system has some nice things too, actually, believe it or not. But either way, the metric system might be a much clearer choice for what you would want for your measurement system, right? But they're still somewhat arbitrary. You can do everything you want to do in both systems, right? The metric system has some advantages, so there's a good reason to pick one over the other, potentially, which is not necessarily true of coordinate systems, but still, similar problem. The cost of having multiple of them is very high. So high that I think we even had a case where a probe crashed into a planet in outer space because someone was using kilometers and someone was using miles or something like this. Let me see if I can pull that up for you. Metric mishap caused loss of NASA orbiter. The engine fired, but the spacecraft came within 60 kilometers, 60 miles of the planet, about 100 kilometers closer to the planet. And it looks like a math mistake, right? Here's the Wikipedia. One piece of ground source supplied by Lockheed Martin produced results in United States customary unit, contrary to its software interface specification, while second system supplied by NASA expected those results to be in SI units in accordance with the SIS. Specifically, software that calculated the total impulse produced by thruster fires produced results in pound-seconds. The trajectory calculator software then used the results expected to be in Newton-seconds to update the predicted position of the spacecraft, right? So this is basically the same thing, right? A probe crashed into a planet not because anyone had a bug in the actual computation, but just because one person assumed they were in one coordinate system and one person thought they were in another, right? And these are like really highly checked pieces of software. So, in games, we are way less rigorous about what we're doing because it's, nothing crashes into a planet when we make a mistake. And so you can understand why reducing these sources of possible unnecessary error are very important everywhere, because they're important even in highly scrutinized software. It still makes it through and causes severe, even in this case, catastrophic errors, right? Where the entire mission didn't go the way it was supposed to because somebody didn't use the metric system or somebody didn't use the English system, right? So I suspect that's all John's talking about, but I don't know. I would say the same thing about endianness. There should be no more big endian processors for the end, period. I think anyone who ships a big endian processor from now on should just be immediately forced out of the market. And the reason is because, again, there's nothing particularly difficult about building software that works across multiple endian architectures. It is not, to use a pun from the previous example, rocket science. That said, it is unnecessary work. There is no reason to choose big endian or little endian. It's arbitrary to a large extent. So the fact that we now have mostly processors that are little endian means let's just lock it down. It's little endian from now on. Hardware people, no more big endian. You don't get to do it. It's over, right? And so I think that would be a crucial thing to just force the industry to do. Big endian is done. We will not program for it anymore. If you ship a big endian chip, no one will code for it. We roundly reject this, like a programmers union or something that goes to the bargaining table and it's like, we will picket your factory if you ship a big endian chip. Because it's hardware companies creating work for software companies. Period. That is all it is. Because we're done. We've proven that little endian can be the only platform that we need. We're doing it right now. Why muck it up, right? Elnar for UK, what kind of memory allocations do you use? Are there any custom stack allocations, pools, etc., or are you using standard malloc new? We are using 100% custom. We don't use any standard malloc or new. And we use stacks. We don't really use pools explicitly per se, but we do sometimes allocate from stacks in fixed chunks, which can then go back on a free list, which effectively creates a pool. So we have in a very limited sense, some pool in like one or two places, some pooling. Did you manually build all the menus on the screen or got it from somewhere? Manually, well, everything we did is built by us. There's no code that it wasn't built by us. We're still calling the C runtime libraries like sine and cosine functions because we haven't put in our own sine and cosine, SIMD sine and cosine yet. But that's about the only thing that wasn't 100% written on stream so far. Compute light propagation 92% seems too high at the moment. Does it? I mean, it's the only thing really doing a lot of work. Roller 9119. Hi, Casey. Would you be able to recommend good resources to learn and practice efficient programming habits? No. I don't know much other than what the sorts of things we talk about. Engineer, can metaprogramming do everything and solve all the world's problems? Yes. Obviously. All right. I think we're actually over time anyway, so I'm going to go ahead and shut the stream down. Let's go ahead and close this up. We accomplished exactly what I wanted to today. That's always good when you don't get hung up on any sort of problematic sort of piece of code. Thank you, everyone, for joining me for the episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with all the source code, so you can play around with it yourself. Tomorrow, we will be doing the sort of movement of the lighting from working with surfaces to working with cubes directly, so that should be interesting. If you want to try that, you've got the rest of the day today to do it. Shouldn't be too hard of a thing to try, although, you know, we'll see. We'll see how long it takes me to do it tomorrow. It might take more than one episode to do. But point being, if you want to play around with the source code, that would be a good thing to try. Change the lighting to be working on cubes directly. It's a little bit challenging, so that might be a fun thing for you to try. Anyway, we also have, obviously, an episode guide if you want to check out the past episode of the series. It's a really nice annotated episode done by Miblo from the chat. It's fantastic. I highly recommend it. And if you want to contribute to projects like that people in the community do, we do have a community fund here on the contribute button that actually lets you contribute sort of a recurring donation that just goes to people who do stuff like that. So it goes to the folks at Handmade Network who hosts the episode guide. It goes to Miblo for making the episode guide. And we are constantly looking for donations to support other projects that are Handmade Hero related. So yeah, give that a look as well. That's it. We'll see you back here tomorrow for some more lighting programming. Until then, have fun programming on your own, and I'll see you all on the internet. Take it easy, everybody.